Hello, everyone. Thank you for joining us for today. My name is Alexandra. I'm working at DataArt as a PR, and today I'm going to be a moderator of our event. And before we start, I would like to inform you that you could ask all the questions you will want during the presentation, and after each speech, we will answer for all of them. And don't be shy, ask as many as you want. And one more important thing, that below in the description, you have feedback form. It is very important for us, and please leave your feedback after the event. And let us begin. Today we are going to have two presentations. And as a first speaker, I would like to invite Jakub Kociubiński. Kuba, are you ready? I think we can start. Enjoy the presentation.
Yeah. Hello, everyone. So today I'm going to present to you the topic. I will talk to you about SRE. The title of the presentation is SRE Quick Introduction. So first, a few words about me. My name is Jakub Kociubiński. I work in DataArt. I'm a team leader there, and currently I'm in a project for the biggest online grocery retailer in the world. So what will we talk about today? What I want to share with you is what is SRE and what are its basic concepts, what's it about, where you can place it on the map of different buzzwords that you have in IT today. And I want to start from what problems does SRE address? Because actually SRE is a response to a series of problems that have arisen in the industry. And so I think it's good to start there. Well, also what I would like to what I would like to convey to you, and I think a quick way to kind of better understand what SRE is by saying that that SRE implements DevOps, just as Scrum implements Agile. Now, you may not know, I will go very briefly into what Scrum, Agile, and DevOps is in this talk, so you don't really have to know it, but I guess for someone who's been in the industry for a few years, it will be probably beneficial to you to get kind of this short introduction. So let's maybe start with a question. How best to develop software? So it's kind of getting to the roots of developing software, getting to the roots of people starting to work together on projects and programs that were more complex and that one person only couldn't really do. So now the question arises, how best to develop software? And now the first answer to that question was Waterfall, as a lot of you may know. Waterfall is a methodology where we try to divide up all of the stages that we want to do in a very linear fashion. And we want to say, okay, we'll do the analysis first, then system design, implementation, and on and on. Now, this was pretty widespread about 40 years ago when it first started out. And now the question is, was this the right answer to the previous question, how best to develop software? Well, it maybe wasn't the best answer. It does work in some cases, but in a lot of real world projects, it kind of failed. So it's probably not the best tool to use in your project. Now, so we could say that we had a second try after that. People recognized that Waterfall had many limitations and responded to that, coming up with something that we now call Agile. I assume that most of you probably heard about Agile, but just a quick recap. Agile is a software development methodology. It was popularized first by the Agile Manifesto. So a bunch of guys that were pretty influential in the industry started talking about what the pitfalls of Waterfall are and other software development methodologies, and they kind of agreed on 4 main values that define, from which then 12 principles arises. So, but the problem with Agile is that it's pretty vague. So you have values like we should value working software more over documentation, or we should value responding to change more over following a plan. And that's all great and well and good, but what does exactly that mean? What does it exactly mean? And what followed is that because this concept became very popular in the software industry, people started adopting it. But because it's so vague, the 2 organizations or even 2 teams inside an organization could implement Agile completely differently. Like and they both, all of them could say we're doing Agile, because Agile is a very high level concept. And so when an organization then came to the conclusion that they want to start doing Agile or want to start being Agile, you could say it was very hard to know where to start, or just to know, okay, what should we focus on first while doing this transition. And so the answer to that, we could say, was or is Scrum. So I'm not saying at all that Scrum is the only way to implement Agile, but it became the most popular implementation of Agile. So Scrum gave you very specific advice, or gives you very specific advice on what roles you should have in your project, what artifacts you should produce, what kind of meetings you should have, and how often, what you should measure, what you should talk about, all of this stuff. And of course, it's not that you can say that if you don't do Scrum, you don't do Agile. That's absurd. And also, a lot of organizations that are doing Scrum are not really doing Agile, and that's also true. But Scrum is a very good way to start. Scrum, because it gives you very specific advice on where to start and when to start looking for improvements. So now, going back to the original question, how best to develop software, is then Scrum the right solution? Well, it's better, sure. It works for sure in a lot of cases, as Waterfall did not, or Waterfall failed. But it has its own problem. So it introduced a lot more agility, a lot more incremental thinking in software development, but it of course didn't solve everything, and it left a lot of unanswered questions and undiagnosed problems. So and we will look to them, to those questions and problems now. So I would argue that after implementing Scrum, after agreeing that, okay, Agile, Scrum makes sense, they are better, they're not perfect, there is a lot of wrong with them, but it's a step in the right direction. Now you could say, okay, we've solved the problems, we solved some of the problems with steadily delivering software that the users actually want in a reliable fashion. But now that leaves a lot of other questions related to software open. For example, how best to quickly ship reliable software? That's another question about developing software that goes a bit more into detail on some of the other things that we want to achieve while developing software. So there was for a long time this divide between development and operations. And so this is one of the things that Scrum really doesn't address at all. Scrum, Agile, because they were more about how do we deliver what? Well, they were addressing the problems of Waterfall more than they were trying to develop a complex system of delivering the best software possible, and of delivering software that was maintainable, that we could ship quickly and reliably. So now we look at another problem that arises here, and this is development versus operations. So you probably a lot of you have seen this, where you have this divide between developers and operations people. And so the devs just want to do their stuff, prepare the version, then throw it over the fence and forget about it. And now it's ops problems. Now those guys have to worry about operating it. So what is wrong with this? It has, of course, advantages, as you know, you have people that specialize in operations. They have different skill sets, maybe different cultures, and they can arrange in a team. You can arrange them in a team, and then you can arrange developers in a team. And well, they can be better specialized in what they do, but you get a mix of two different groups that have actually different interests. So they have opposing interests, you could say, because for the developer, the developer just wants to do the most changes he or she can as quick as possible, and just get it out. Just do as many features as you can. While the operations people, they want to keep the system stable. That's their top priority. So they don't want to have any outages. They don't want to have any problems. So they will say, hey, hold on. We had this kind of problem before, this kind of problem before, this kind of problem. We should check for them. And that's all well and good. But because the sides are those teams have opposing views, they will always crash into each other when you get some big failure, and then they will start the blame game. No, it wasn't our fault that this happened. It was the developers. Oh no, we developed it well, but just the operations people didn't operate it well. And so you get this, and so everything becomes slower as a result of that. And then an answer to those problems, just as with Agile, just as with an answer to Waterfall was Agile, an answer to those problems that Agile and Scrum kind of forgot was something we call DevOps now. So this is trying to bring those two groups together, of developers and operations people. So as we said, developers want agility, while operations just want stability, and they need to cooperate. So in the case of DevOps, we don't really have a manifest. We didn't have people come together and kind of synthesize all of that for us. But we do have a set of practices and kind of a set of very high level ideas here. So we now see an analogy to Agile here, because you could take those DevOps ideas and implement them differently in two different teams, and you can implement them differently into different organizations. So the roughly main ideas of DevOps are to reduce the organizational silos. So we don't want to have closed teams that do stuff as that hoard information, don't want to share, and don't want to cooperate with others. We want to accept failure as normal. So we want to say, hey, failure is just a normal part of operating a service, a system. So we should plan for it. We shouldn't fear it. We should always try to implement changes gradually. So not do the big bang release once a year where everything fails and we then scramble for a month to bring the system back up. And we should measure everything, because gut feeling isn't really a good indicator of where we should go. And now we come to SRE. Finally, after 10 minutes of the talk, this is because this is also why I said that I think it's important to understand the problems that led to SRE. So first of all, we could say that SRE, as Scrum is an implementation of Agile, SRE is an implementation of DevOps. It was created and promoted by Google, and it gives very specific advice on the roles you should have, the artifacts you should have, the meetings you should have. So it's maybe a bit less specific than Scrum, but still it gives you a basic guideline of where to start and how to go about operating your service. Oh, okay. I just got information that I'm not sharing my presentation. Is that true? Okay. So was I talking for the last 10 minutes without my presentation? Really? Okay. That's good. Okay. Is it on now? Am I live or? Okay, so that's all. So I hope you got something from that in case you didn't see the presentation. Yeah, well, so SRE, service reliability engineering, as I said. Now let's get maybe to the guiding principles. So there are pretty much 3 guiding principles of SRE that we should look at. First one is we need to say that reliability is the most important feature of any system. So if your system isn't reliable, then it's probably no good. So it doesn't matter what features you have. It doesn't matter what you provide. It's just it doesn't bring any value if it's not reliable. Now, what does reliable mean in that case? Well, what we need to acknowledge here is that reliability is decided by the user. So it doesn't matter what your monitoring tools say. It doesn't matter how many CPU cycles you have left, or memory, or this kind of stuff, or network. It doesn't matter. It depends. It depends completely on the feeling of your users, of the feeling of your reliability, of the reliability of your systems, rather. And so we also need to try to chase the better reliability always, or try to go on the next level, if it makes sense for us. So going a bit more into reliability is the most important feature of your system. So first of all, we need to acknowledge that trying to reach 100% reliability is not a good goal for most systems. So there are notable exceptions if we look at, for example, peacemakers, or if we look at those kind of products that really need to be 100% reliable. But all of the other stuff really doesn't. It really doesn't. It doesn't mean that the system can fail whenever it wants, but most users are really able to accept a lot of outages, or a lot of problems, until it doesn't affect them in a way that they cannot get the value that they want. So the value is actually the most important thing, the value for the user, for the customer. So because a lot of outages can bring quickly a bad reputation to your service, you also don't want to go too low on your reliability. But it's very important to realize that we should aim for something lower than 100%, and something that's lower, and we shouldn't start with the assumption that our system will be always available, because that doesn't make any economical sense. If a if a user perceives a system as unreliable, even if it's not our fault, or even if we aren't directly responsible for that, it doesn't matter. So it's the perception of the user that matters. And the engineers can often be surprised how users use their systems and what they are willing to tolerate. And for sure, people that are designing systems so a lot of the time aren't really aware of that. So this is why it's very important to measure reliability, and we will get to how to do that best later on. Okay, and we should always try to get better reliability, of course. So 100% isn't a realistic goal, but if we get, let's say, 995, 99 and 5% of reliability, well, that's great. I mean, but if we can get a bit more without investing too much, that's also great. So then we should try to do it. But we should always be aware of what we're sacrificing and try to do better. So now we will get into a few important notions, or you could say definitions that we have in SRE, that if you read up on SRE, or if you'll get more into it, you will for sure hear about. So the first thing are SLOs, service level objectives. Now, as we said, taking reliability to extremes is really unproductive. You can't really have 100%. So, well, you can. It's very, very, very hard, and it's very, very, very expensive. And for most systems, you don't need 100%. You don't need to spend that money and make that effort. This is where the SLOs comes in. So most businesses are always needing new features, and this is why we need to really define what is the baseline of reliability that the business is willing to tolerate. Because if we decide that we want to ship new features, and most businesses always want to ship new features, then we should say, okay, our reliability will be this, and we will try to stick to that. And if we will be deploying new features and getting outages, getting problems, getting errors, as you do, that's okay, as long as we are reaching that level that we are committing to. And this level is the SLO, service level objective. So as we said, we need to control that balance between being reliable and introducing new feature, experimenting, getting new stuff, and upgrading our hardware, all of those good things. We need to set a level that everyone in the company agrees on. So not only the product people, not only business people, but also developers, also sysadmins. So the organization should have a target that it's trying to achieve, and everyone should agree on it. So there is much more cooperation throughout the development team, operations team, business people, and everyone. So the SLO should be the dividing line between happy and unhappy users. So what you want is the SLO to tell you when the users are happy enough to be using your service and they don't really care about the next 9 that you get on your availability, and when they are not happy. As I said, it must be agreed by everyone. And an example is we could set our availability at 99, 95%, and that's an SLO for something. So availability. Now we will talk a bit more. I will give a concrete example on what that could mean. But it's important to know that SLO is this level of happy, unhappy customer. Now, what a lot of you may have heard is SLA. So this term SLA. So The difference between SLAs and SLOs is that an SLA is a target that you agree on. It's agree on with the customer or with someone, and if you break it, there's a penalty for it. So this is different, a bit different than an SLO. An SLO is something internal. We want to measure when we are failing the users and when we are making them happy, and we want to plan on that. And as an SLA is something different. It's more of, if you break the promises you've made, you will pay, or you will have to you will get a fine. And this is why usually you would set your SLA a bit higher than an SLO. So another concept that is important here are SLIs. So we had SLOs, the line between happy and happy. Now, to know where the line lies, we need to measure something. We need to know what we are measuring. And this is what SLI is. It's a metric. So it should be the user happiness in metric form, you could say. So when we say that there is a line, we need to know on which scale to put this line. What's important with SLIs is to realize that the stuff that we usually measure, or the operations people can, well, or historically would usually measure, are CPU, memory, server statistics, what's net traffic statistics, this kind of stuff. Now, it's all well and good to measure that stuff. I'm not saying it's bad, but you need to really define your SLI. So if you're measuring everything, you're not really measuring anything, because you don't know what to react to. You need to beforehand realize and define what you will actually measure, what your metric is, and then set an SLO on that metric. And you should also agree, it should be measured over a long period of time. So you can look at it in a more time-based manner. So this is roughly how SLOs and SLI relate to each other. So you have the metric, that's the SLI, and then you have the dividing line, SLO. SLIs are usually presented in a way where you say, okay, let's take all of the good events that happened, or good things that happened, so, or divided by valid events times 100%. So this is why you will usually define them as 99.5, 99.9, and this kind of metric. It's also important for an SLI to be very well correlated with user happiness, and to be correlated in a way that's easy to see. Let's say, so when you look on the left side of this example, if you look at this metric, it may correlate. It correlates with user happiness, but it's when you zoom in to those areas that we see here, happy, unhappy, it may be hard to really understand what's going on here. So if you look at the point on that scale, it's hard to say, okay, is the user now in this moment happy or not happy? Because if you look, for example, at the left, at the beginning of the bad experience here, it's pretty high, but it's a bit lower than the top of the good experience. So is it bad or not bad now? So if you look at the right side, this is another metric that you could maybe use, but this is a bit much more stable to see exactly, okay, now user is happy, now user is unhappy, and we should prefer this kind of metric on the right. That's a bit more stable to see. Short example of SLIs, so and SLOs. So if you say, hey, I want my site, my website to be available 99.95% of the time, you could say, okay, a good SLI for that. One of the SLIs, we should always define more SLIs, but one of them may be, hey, I will do an HTTP GET and see what comes back, and I should get an OK to 100 response, everything's fine, 99.95% of the time. So this is how you would define it. Now, if we look at this, we see that when we define SLOs and we say, okay, we have 99.95% of availability, we then get actually 5% of unavailability. And this is something that we are now planning for. We are not saying our service will be always available 100%. We are actually planning for 5% unavailability. And this is, now we know how unreliable our service can be. And we can plan for it. So if we look at outage math, what you could say, so if a service is supposed to be 99.95% reliable, that means we get 20 minutes, 10 seconds of downtime every 28 days. Per year, that is only 4 hours and 20 minutes. So it's not a lot, but we do plan for it and we can plan for it. But if you say that we want to have 99.999% unavailability, that means that per year, it's only 5 minutes and 40 seconds. So it's a big difference. It's really a big difference. And the question is, do you want to make that effort? Now, what you could spend your error budget on? You could roll out new features. You could say, okay, we have an hour left, for example, this month of unavailability. Let's roll a feature out and spend that budget on the errors that will probably come with the new feature. We could do planned downtime. We have to expect hardware failures and other stuff. So what's also important is that the teams share ownership of systems. So important in SRE is you need to share the systems. It's not that operations are only responsible for incidents. The developers should be also responsible for them. Everyone should share responsibility. This is how you align the values and the incentives in teams. You should use the same tooling everywhere. So it shouldn't be that being a developer, if you want to look at how the production systems are configured, you have to learn a whole new versioning system, a whole new ticketing system, a whole new whatever other system you need to do it. You should share as many tools as you can so that it's easy for you because to check a lot of this stuff out, because you can just use the tools that you normally use for your job. What's important is also continuous integration, continuous delivery on the next slide. So everyone needs to be integrating their changes all the time. This allows for small incremental change, and it's easier to roll back those kind of small changes or from the code. This leads and give us the possibility to do continuous deployment so that you can take those small changes that you commit and build and test and run on your local environment, and then you can just deploy that small change. So this allows us to build automatic reduction policies. So you can, if you have 5 minutes left in your error budget and you do a feature release and you have an automatic fallback that if it doesn't work, you will just go back, then those 5 minutes might be enough for you. If you have to do it manually, for sure you will fail. So, and you get less human error in the process. What's important also is that what SRE is focusing on is to remove toil. So toil is doing a manual repetitive process that grows. So that grows with the as fast as the source of that process. So if you have to register each user manually, if you have to do something for a user manually, the more users you have, the more manual toil you have. So those are the kind of stuff that you really can and should automate. And SRE makes it very clear that the developers or SREs or whatever the roles you will assign in your teams, but people should have separate time to do this automation and to automate as many things as possible here. But to know what to automate and to know what to measure, what your reliability is, you need to measure. You need to measure everything that's important. With the reliability, we have SLIs. We talked about that. We get our metrics, we define them. With toll, it's a bit more difficult, but you can do it. You can look at the types of work that the team is doing. You can look at the type of activities that the operations people are doing, and try to periodically check if you are reducing the toll, reducing the manual, repetitive stuff that everyone needs to do every month. So now, final slide. I'm already 5 minutes out of time. So final slide. As I've said, SRE implements DevOps. We can see that the 5 main branches of DevOps that we defined, we can see how they now relate, how they are implemented in SRE. You get the shared ownership of systems and same tooling as reducing silos. You've got SLOs, SLIs, and the error budget for accepting failure as normal. So for planning for failure. You've got continuous integration, continuous deployment for implementing gradual change. You have removing toll, automating all the things, and measuring them as the last 2 principles. So thank you very much. I hope I've explained SRE on a very basic level to you. I hope that the first 10-15 minutes without the presentation weren't totally lost and that someone stayed. Well, we have time for questions. I have our live chat open, but I don't see anything. So if you have any question, please ask. If I screwed up and I'm not seeing the questions because of something, then Sasha, please let me know.
Yeah, for sure.
Yeah.
Thank you, Kuba, for your presentation.
Yeah.
And also, in case if you will come up with the question after the presentation and after the event, you could ask it under the video, and we will try to answer all of them. And also, you can find our speakers on social media. I think they will help you with some questions.
Yeah, of course. If anybody has any questions about this, please write here. If not, yeah, exactly. Please try to reach out a different way.
Okay, I think we can continue and switch to the second presentation. Thank you, Kuba, once more.
Thank you.
Okay, and if no question, we will proceed. Let me introduce our next speaker, Pavel Khrulev. Are you here?
Yes. Hello,
okay.
everybody.
The stage is yours, and enjoy the presentation.
Yeah, let me share my screen at the first thing. Okay, so hello, everybody. My name is Pavel. I've been working in DataArt for more than 5 years. Mostly I have a software development background. Currently, I work as a solution architect, and I specialize in clouds mostly. And today, I want to talk about multi-account environments in AWS. What is this? How it can be used, and why does it exist at all? And just on a very, very high level, describe what services we have, what tools we have in order to live and in order to manage multi-account environments in AWS. I think this topic actually is very huge. It's not possible to cover it like in a 30-40 minute presentation. There are a lot of services, a lot of things, but here in this presentation, I would like to highlight the significant thing that I think is important, and just to share my opinion on some things. First of all, I would like to talk about what is multi-account environment and how is it implemented in AWS. Then I want to talk about some services, to tell you about some services that are related to multi-account environments. And at the end, I want to tell about challenges we have when we design multi-account environments. So multi-account environment and single account environment. Uh, why uh, why could we use multi-account environment? What is the advantage of it? So in my opinion, there are three main advantages. Actually, there are more. If you read AWS documentation or some other sources, you can probably find a very big list of the advantages of multi-account environments. I highlight for myself three main advantages. Account level isolation. What does it mean? So when we have resources isolated on the account level, that means a lot of things. For example, from the security perspective, that means decreasing blasting radius. For example, if you have all resources in one account, if your account is compromised, that all resources that you have are compromised. If you separate all your resources in different accounts, that means that you will decrease the blast radius of your infrastructure. Also, AWS has a quota per account. There are some quota per resources, there are soft limits and there are hard limits. And if you are a very big organization, enterprise, you probably will meet these limits very, very soon. And that might be a problem because you have a lot of workloads, you have a lot of resources, you want to put them just in one account. You will definitely meet this quota. And segregating these resources into different accounts can allows you to have actually separate quota per each account. And I think that's an advantage for big organization, for and actually multi-account environments are used by big organization, and that's a good choice for them. So, and quota, one of the advantages. And logical structure of resources. If you put all your resources in one account, it is really hard to structure them. Yes, you can use tagging, you can use some other techniques to structure them some way, but using different accounts, you can logically structure them by purpose or by department or by something else. They will be structured logically, isolated from each other, and that's actually very good. What about single account? Does it have any advantages for big organizations? So single account is definitely easier to manage and control, because when you have more and more accounts in your organization, you have an overhead for that, because you have to manage credentials for these accounts. It's harder to manage these accounts because there are more and more of them. It's harder to control what happens inside of each account. And when you have just one account with all your resources in AWS, it is definitely easier to manage and control. But actually, that's the only one advantage I can see regarding the single account environment for big organizations. And yeah, that's good. So we can use multi-account environments for our big organization, And what tools do we have for that? Actually, before 2017, when AWS released AWS Organizations service, that could be actually a hell, because for just imagine you have one account, you have another account, you have like 10 accounts, and all these accounts have separated billing. So if you have 10 accounts, you have 10 separate bills for these accounts. Also, it wasn't possible to centrally structure them and manage them. That could mean that you probably managed these accounts in Excel file, or just invented some tools to manage them. There were no organizational level services, just there were no such tools that allowed you to apply some policies or apply some changes on several accounts at the same time. You should do you should do all things in one by one account, and probably repeat a lot of things there, and there was a lot of overheads. And in 2017, AWS released Organizations, and everybody is happy, as we can see at the right-hand picture. But okay, we have AWS Organizations. AWS Organizations allows us to manage and structure accounts. It allows us to create organizational units. It allows us to create nested structure of these organizations. It allows us to have consolidated billing and centralized cost exploration. You can see all expenses, all costs in your accounts just in one place. And also, it allows you to use advantages of something like reserved instances, because when you buy reserved instances, more reserved instances you buy, more discounts you have. And for organizations, all of this, all their workloads is consolidated, and they can use it for discount. Before AWS Organizations was released, it wasn't possible. Also, their organization level services were released. We'll take a look at some of them a bit later. And multi-account policies were introduced. So currently, we can apply some policies for several accounts, or even for a whole organizational unit, and we can do it centrally, just in one place. And that wasn't possible before. But talking about big organizations and about enterprises, actually, they have a lot of workloads, and mostly they have very strict security requirements. And actually, what is the best way to live in a multi-account environment, to live in AWS Organizations? What is the best way to start? How can we organize our structure? If we want to aggregate logs and we want to have a separate account where we have these logs aggregated, what should we do? What is the best approach? What AWS well-architected framework recommends then? So different organizations started to invent their own things. And when, as from software development, when everybody invents their own things, then come up a helper, come up a framework that allows just to standardize some things and don't invent the wheel. And AWS did that framework. They introduced landing zones. landing zone, that it is, we can call it a framework. Actually, this is a solution that allows us to start living, to create AWS organization and manage it in the most secure way, and to be sure that everything is architected well and that well-architected framework principles are followed. Landing zone, that's simply a set of templates that you can deploy in AWS. It allows you to create AWS organization. It creates account vending machine that allows you to create new accounts with some baseline resources in this account. That means you can create a new account with everything you have to be provisioned in this account to use it. Any baselines, any rules, any design of VPC that you would like to have a newly created account. That is possible with account vending machine. Also, landing zone provided started structure of your organization, and it created several accounts. For example, we can see it creates shared services account where we can share our services. For example, we can share our VPC there and share it with our account, with other accounts. Also, it created log archive accounts. That an account that aggregates all logs from all other accounts, and all other accounts by default have a baseline created to put their logs in log archive account. So landing zone creates it by default. It enables CloudTrail, aggregates all CloudTrail logs. It enables AWS config and aggregates all AWS config logs and records just in one account you can use to audit your environment. Also, it creates security account that allows you to assume cross-account roles to audit other accounts. Also, it has SNS topic for all security notifications from other accounts. So it's just one place for security department where they can do audit, where they can get security notifications, and where they can get Amazon Guard Duty enabled. So I talked about a lot of services. Some of them, we will take a look at some of them a bit later in this presentation. And the landing zone itself is actually AWS code. It is a set of templates and the manifest file that is deployed using AWS code pipeline. It deploys AWS Service Catalog products, including account vending machine. It deploys all baselines for all accounts. It creates AWS organizations. It enables AWS SSO service, and it create core organizational unit with all basic accounts. And you can actually modify it, you can customize it, but there are a lot of code. Also, you can deploy your landing zone using Terraform project. Actually, this Terraform project just deploys this code pipeline and everything related to the landing zone with Terraform. Or you can use AWS recommended way. You can just put your manifest file in S3 bucket. You can edit cloud formation templates there. You can edit manifest file there, and you can deploy AWS code pipeline, which template is also provided by AWS. So this is the landing zone. This is something like a framework that allows us to create a multi-account environment in AWS and live there and control it, but it is completely managed by code. And actually there are a lot of code, and unprepared person can be really just get lost in tons of code. And the next iteration, the next evolution of the landing zone becomes AWS Control Tower. AWS Control Tower, it is an AWS service that allows to deploy landing zone without managing any code. It was released in 2019. It's a relatively new service, and that's the easiest way to set up a landing zone. Actually, you can just click a button and your landing zone is set up. You have a multi-account environment and everything is baselined with best practices and well architected, and that's a good start. Then you can automate your setup with some guardrails which they have created by default. So if we talk about the landing zone, you have to implement guardrails there. You can create a piece of code with some guardrail like AWS config rule, for example, or service control policy. You have to deploy it. And in Control Tower, you have some guardrails implemented. You just can click button, enable me this guardrail. For example, I don't want to have I don't want to have security groups that allow to connect by SSH from outside, from the internet. And there is a guardrail. You can enable it, and it will detect all resources that don't satisfy this rule. And these guardrails under the hood, they use either service control policies or AWS config rules. Those one which use service control policies, they are called preventive rules because they prevent some actions. And those one who use AWS config, they called detective rules because they detect some non-compliant resources in your environment. You can apply these guardrails, and also account provisioning is fully automated with Account Factory. You just need to type an email for your new account. You can choose VPC configuration, and your account is created. And it has dashboard where all information about your accounts, about your non-compliant resources are aggregated. You can review your organization. You can review what guardrails are enabled for such accounts or organizational units, what non-compliant resources you have. That's a very powerful tool for governance when you review resources that you have in your AWS environment. And also, it has automatic updates, because when you use landing zone, for example, best practices improve, and there are new version of the landing zone that AWS provides. Templates are updated, and AWS now releases the new version of the landing zone. If you don't use Control Tower, you have to update it manually because you manage this code. You have to download the latest version of the landing zone templates. Then probably you have to refactor some things because probably you customize this a bit. And updating landing zone to be to always be to always use best practices, actual best practices, relevant best practices, you it's actually becomes a pain to maintain this code. And AWS Control Tower manages this code for you, and you get automatic updates. You can just click the button, and all baselines, all guardrails, all best practices are updated just for you. But actually, Control Tower has its disadvantages, in my opinion. It is currently not customizable enough. You can't create custom guardrails, for example, yet. If you would like to have something that is not included in the AWS Control Tower, that means that you probably should implement your own AWS config rule or your own service control policy to extend your governance on your environment. And AWS Control Tower currently is quite limited in that. But actually, I think, and AWS said that landing zone as a template is deprecating, and currently only recommended way to deploy a landing zone is AWS Control Tower. And they're working, they're implementing a lot of features coming. And I think that AWS Control Tower service definitely has some perspectives for enterprises, for big organizations to migrate into the cloud or to start a lot of projects in the cloud, to have very big environments there. I think AWS Control Tower will become a standard at some point. And that's why I think that probably that's a good time to start trying it, working with it, learning it. Okay, next, I want just to take a look at some features that AWS organizations provide us, or just some services that we have that we may use in multi-account environment. And one of the most powerful features is organization policies. AWS Organization Service currently has three main policies. Service control policies. They allow you to set permissions on account level. That's almost the same like IAM permissions you can set for your IAM users or IAM roles, but it works on account level. That means you can prohibit doing some things for some account, prohibit using some services for one account, and allow it for another account. So the same thing as IAM permissions, but it works on account level, and you can centrally give some permissions to accounts in your environments. Tags policies allows to standardize requirements to tags, because when you have a very big organization and you have a lot of resources, that's really important to tag all of your resources, to segregate them in the reports, to actually to structure somehow your resources in your environment. And tags policies allows to standardize requirements to these tags on the organizational level. You can set, for example, these tags should be necessary. Please apply them to all of your resources all the time. And they should have the following format, and values for this tag, maybe like limited options, for example. So that's very powerful to structure all your resources in your organization. And backup policies allows to standardize and control requirements, backup requirements to all AWS resources. For example, you decide on organization level that you must do a DynamoDB table backups every day. You can create a policy for that, and that enforces doing that for all accounts in your multi-account environment. And that's a relatively new feature, I think, that was released just last year, probably half a year ago. And I think that also might be used for governance purposes. The next service I want to talk about is AWS SSO. AWS SSO allows you to log into all accounts in your AWS environments just through one single sign-on page. Before that service was introduced, you had to go to each account, create identity provider there, then create a role, attach it to this identity provider, and then through AWS console, you could log in your credentials of your identity provider to this account. Then you have to go to another account and make the same things there. With AWS SSO, you can do this centrally. You can just integrate some identity source, and you can log in to any account in your AWS environment you have access to. And also, you can log into business cloud applications or any actually SAML application. For example, you can install Jenkins in your AWS environment, and then create SAML federation to your AWS SSO, and you can log into to Jenkins through your AWS SSO page. So how actually AWS SSO supports several identity sources. It supports AWS Managed Active Directory, and AWS Managed Active Directory can be connected to on-prem Active Directory as an AD connector or through Active Directory Trust. And you can use on-premise Active Directory to log into AWS through AWS SSO. Also, it supports Azure Active Directory, Okta, and Ping Identity. And I think actually they're going to implement more and more. They are going to support more and more identity providers. Also, you can, as I have already said, you can log into your AWS environment or any account just from the single page, and you can get programmatic access provisioning. For example, you can log into AWS SSO with your credentials of your identity provider, and then you can choose programmatic access and get temporary credentials for programmatic access. You do some things what you would like to do with your CLI, for example, and after some configurable time, your credentials, programmatic credentials, are expired. And that's more secure way than creating AWS IAM user and creating programmatic access credentials there, copying them, and that's it. So you just copy them once, they expire in an hour or 8 hours, and you can just get new credentials anytime, just logging in with your user of your identity provider. And AWS SSO, this is a part of the landing zone. Landing zone by default deploys this service, and if you deployed landing zone through as a template or through Control Tower, you have this installed and ready to work. Only thing you left to do is just to choose your identity source and integrate it. AWS Service Catalog is one more important tool and also a part of the landing zone. Actually, account vending machine that creates new account in the landing zone is implemented using Service Catalog. Service Catalog simply allows you to create a template and share it with other accounts to deploy. So, for example, your admin defines VPC design that is standard in your organization. You can create a template, you can upload it to Service Catalog, share with other accounts, And users in these accounts can simply click deploy, and this template will be deployed using AWS code pipeline and CloudFormation stacks. And your users in your accounts have this VPC, which is designed as standardized in your company. And this is used in landing zone, in account vending machine, and this service catalog creates a new account, and all baselines are required for this account. And you can monitor account creation there, or any products creation there, and you can manage them. You can control drift of these accounts, and it is centralized. That means you can share it with all other accounts, and then from one place you can see what is deployed and in what state it is currently in. The next important service is AWS Config. AWS Config simply record all configuration change of any of your resource in AWS. It records the resource, it normalizes it, and it uploads it to, for example, S3 bucket, or it can be accessed through config APIs, and it can be sent in SNS or in SQS, and it just records all changes in your resource. If you change something in your resource, the new state will be recorded, and you can track all the changes of your environment. And also it allows to create rules. That means that anytime your resource in your environment is changed, it can be evaluated against some rule and marked as compliant or non-compliant against some rules. And landing zone guardrails using AWS config for creating detective rules. And all detective non-compliant resources are aggregated in Control Tower dashboard, and you can see, for example, if you have a rule not to create buckets with public access, you can see all these buckets in your dashboard, and you can go to account owners and say, okay, let's fix it. And that's aggregated on organization level, and that's important part of the AWS organization services. And here I also would like to mention some very useful services that work on organization level. This is Resource Allocation Manager. It is a service that allows you to share resources between accounts. You can just create a share, select some resources, and share them between accounts. Firewall Manager allows you to control your security groups and WFAF configuration centrally, because when you have a lot of accounts, they create their own security groups, and sometimes you want to control what they allow in their security groups, or you want to define some applications. You can say that these kind of applications should have these security group rules, and this kind of application should have these security group rules. And you can manage these centrally on the organization level using Firewall Manager. And Guard Duty is one more important tool regarding security. This service analyzes CloudTrail logs and VPC flow logs in all accounts in your environment, and it intelligently detects security incidents. And also it has some tools to automatically reconcile them, to fix them. You can use Lambda functions to fix some events, for example. And currently it has about 20 default events, as I remember, that can be detected and fixed. That's all about service that I wanted to tell about services. And actually, what challenges I think we may have when we design multi-account environment infrastructure, when we design multi-account infrastructure in AWS, that's my opinion. So, that's something that I got from my experience. I think there are three main challenges: defining restriction level, centralization versus decentralization, and defining area of response. So when you work in multi-account environment and you actually use landing zone, which uses best practices by default, and everything is well designed, but there are some things where you have to decide on your own, and which depends on the client needs, on some specifics of organization you land the resources into the cloud in. And defining restriction level, what does it mean? So we have a lot of policies. We have service control policies. We can actually follow the least privilege principle and deny everything, and just leave some small permissions they have to continue working in this account. And it has advantages and disadvantages. If your accounts are homogeneous, I mean they are uniformed, they are almost the same, that's fine. You can just restrict, you can highly restrict everything in all accounts, and that should work because they're almost the same workloads there, accounts almost the same structure. But if your accounts are not homogeneous, that means you will have a lot of exceptions, and you will go to exceptions hell. And at some point, probably each account will have its own policies, which is not good. And taking into account what is the organization and what's the specifics, what you deploy in this account, you should define restriction level. Should you restrict everything, or it should be quite loose? Centralization versus decentralization. Centralization is good. You can manage all things just in one place, and that's great. But that's also bad because everything, probably some important thing, they are just in one place. For example, you can centralize your DNS records, and all accounts and all DNS records will be in one account, and it will be and all other accounts will depend on these records. And that means if some person who has access to network account can fail or do something, it may be a bad actor, that means that will be a bottleneck. You can just break everything down in your environment because you have a bottleneck, because something is centralized. And decentralization, that's also has its advantages and disadvantages, because it gives more power to accounts, but it's harder to manage them. But there's no single point of failure. Each account is accountable only for resources they have in this account. And you have to decide each time you design multi-account environment in AWS, you have to decide centralize something or not centralized, and you have to do it sensible on having your inputs from the company, from your organization. You adopt the cloud. And defining area of response. What we allow to do account owners, what we allow to do for developers. Do we want to control everything by cloud team that manages all the cloud? Or Just we want to give all the power in the account to account owners and let them do everything they want in this account. That's a that's a to be or not to be. That is the question, and that's the question you have to answer individually in each project and for each client and in each account. So I think that's it from my side. Thank you. If you have some questions, but I think you still have some questions regarding SRE, as I can see. But if you have some questions regarding multi-account environments, landing zones, control tower, I would be glad to answer them.
Okay, thank you, Pavel, for your great presentation. And also, as I mentioned, if you have some question, you can ask it in the comments, and we will answer for all of them. Okay, in case we have not, that's all. Thank you for your coming. Thank you for your time. And also, I would like to remind you about our feedback form. You can find it directly below in this description. And also, if you like to join our future events and be up to date with us, please follow our social media. Also, you can find it in the description below. Okay, thank you guys for your presentation, and thank you all for coming, and have a nice evening.
Thank you. Bye.
Thank you. Bye.
Thanks. Bye.